Hello, this is Mrs. Sargent, and this is lesson 4.6, Lewis structures, multiple bonds, resonance, and exceptions. So last time we talked about Lewis structures with single bonds only. Today we're going to talk about double and triple bonds, as well as resonance, which is shown here at the bottom of your screen, where the double bond is switching places, and then exceptions, where an atom can have more or less than 8 electrons. So the steps to draw a Lewis structure, these are similar to what we talked about for single bonds, only we have revised them some. So again, you're still going to just count all of the valence electrons. You're going to arrange the atoms. You want to have as much symmetry as possible and put the element with the least number of atoms in the center. You're going to single bond everything, and you're going to subtract the electrons from the total. One bond equals 2 electrons. We've done that already. Your new information is coming here in step number 4. You're going to count the number of electrons needed to complete the octets, but for every 2 electrons you're short, you're going to make a multiple bond. First, you're going to double bond, then you're going to triple bond. You still want to keep the molecules as symmetrical if possible, and you do not want to put any multiple bonds on hydrogen. Remember, hydrogen only has a single bond. It's never going to have any dots or more than one bond. In step number 5, you're going to recount the number of electrons needed to complete the octets. If you have enough, then you can apply the dots. Otherwise, you'll keep going on step number 4 until you have enough. So we have 2 examples here. We have oxygen and we have carbon monoxide. So oxygen, we have 2 oxygen. Oxygen has 6 valence electrons. That's going to give us a total of 12 electrons for our Lewis structure. We only have 2 atoms, so we're just going to put those 2 atoms side by side. We're going to single bond them, and we're going to take away those 2 electrons from our total. So we have 10 electrons now. Now we need to go back and assess how many each oxygen needs. Well, this oxygen is sharing 2, so it needs 6. This oxygen is also sharing 2, so it needs 6. So we need 12. So we are 2 short, so we need to add in a double bond, and then we need to go back and reassess the needs. So 10 minus 2 gives us 8. So we now have 8. Well, oxygen is sharing 4, so it needs 4. This oxygen is also sharing 4, so it needs 4. So we need 8. We have 8 and we need 8. So now we can just apply our dots because this is zeroing out. And remember, I told you right now it really doesn't matter where you put your electrons or your dots. Just it can't go on the side of the atom where the bond is, but you do want to make it as symmetrical as possible. So for carbon monoxide, we have 1 carbon. Carbon has 4 valence electrons. We have 1 oxygen. Oxygen has 6 valence electrons. So that's going to give us a total of 10 electrons. We're going to put carbon and oxygen side by side and single bond. So subtract those 2 involved with bonding. That gives us 8. So we have 8 electrons left for our Lewis structure. But if we look to see how many we need, well, we have 2, so we need 6 for has 2, it needs 6, so we need 12. So we are 4 short. So for every 2 that you're short, you have to add in another bond. So I'm going to add in 2 bonds. I'm going to subtract those 4 that are involved with those new bonds from my total. So we now have 4. So we have 4, and then we need to reassess our needs. Well, carbon is now sharing 2, 4, 6, so it needs 2. And oxygen is sharing 2, 4, 6, so it needs 2. So we need 4. That zeroes this out. So now we can just apply the dots to our Lewis structure. Take a minute and try CO2 on your own. Welcome back. We have 1 carbon. Carbon has 4 valence electrons. We have 2 oxygen. Oxygen has 6 valence electrons. So 12 and 4, that gives us 16. So we're going to put carbon in the center because it has the least number of atoms. And then we're going to put an oxygen on each side of it. And then we're going to single bond our atoms together. So we're going to subtract 4 from our total. So we have 12. So now, oxygen has 2, so it's going to need 6. Carbon has 2, 4, so it's going to need 4. Oxygen has 2, so it's going to need 6, so 12. And then 4 is 16. We have 12. We need 16, so we are 4 short. So with this, we're going to add in 2 bonds, but we're not going to put them all on one side. We're going to even them out so we have symmetry. So we're going to put a double bond there and a double bond there. And then we're going to subtract those 4 from our total. So now we have 8. And then we got to reassess the needs for each atom. So oxygen has 4, it's going to need 4. Carbon has 2, 4, 6, 8, so it doesn't need any. And oxygen has 4, so it's going to need 4. So we have 8, we need 8. So now we can just apply the dots to our Lewis structure. And that's CO2. So resonance is when there's more than one valid Lewis structure. The location of the double bond can be different as long as it is between the same elements. So we're going to start out everything the same way. We have 1 sulfur. Sulfur has 6 valence electrons. We have 3 oxygen. Oxygen has 6 valence electrons. And so that is going to give us a total of 24 electrons. We're going to put sulfur in the middle, and we're going to arrange the oxygen around it. Single bond them. Take away those that are involved with bonding from our total. So we now have 18. So now we need to go and assess the needs. Each oxygen is sharing 2, so it's going to need 6. Sulfur is sharing 6, so it needs 2. So we have 18. We need 20. So we are 2 short. So we can't, there's no way that we can make this so that it's as symmetrical as possible. So what resonance says is that I can put the double bond here, or I can put the double bond here, or I can put the double bond over here. It doesn't matter. All 3 of those places are valid places. It's just wherever you decide to put it. So then we're going to take away those 2 that are involved with our bonding. So that gives us 16. So we now have 16. We need to reassess our needs. And I always reassess the needs for each atom. Even if I know it hasn't changed, it just helps me keep track of everything. So this oxygen is sharing 2. It's still going to need 6. this oxygen is sharing 2, so it's still going to need 6. 2, 6. This oxygen is now sharing 4, so it needs 4. And then sulfur now has 2, 4, 6, 8, so it does not need any. So 6 plus 6 is 12, plus 4 is 16, so we have 16, we need 16. So now we can just apply the dots to our Lewis structure. So that is resonance. We have another example of resonance, and I think that this one is a little bit more difficult. This is a polyatomic bicarbonate. So to start off with, we have one hydrogen. Hydrogen has a 1 valence electron. We have one carbon. Carbon has 4 valence electrons. We have 3 oxygen. Oxygen has 6 valence electrons. So 1 plus 4 is 5, plus 18 gives us a total of 23. We have a negative charge, so we are gaining 1 electron, so we're going to add 1 to this. So now we have a total of 24 electrons. Carbon is going to go in the center. And then we are going to arrange the oxygen around it. But this hydrogen is off over here to this side. So this is, there's nothing bonded to this side of the atom. So I think that this might throw people off a little bit, but that is the arrangement of these atoms. So now we need to go and assess our needs. So we take away our electrons involved with bonding first. 2, 4, 6, 8. 24 minus 8 gives us 16. So we have 16. How many do we need? Well, hydrogen has its 2, so it's not going to need any. Oxygen has, this oxygen has 4, so it's going to need 4. This oxygen has 2, so it's going to need 6. This oxygen has 2, so it's going to need 6. Carbon has 2, 4, 6, so it's going to need 2. So 6 plus 6 is 12, plus 6 is 18. So we have 16, we need 18. So we are short 2. So now we have 1 double bond to put in. We can put the double bond either here or here. We can't put it here because this arm looks a little bit different. So I'm going to put in the double bond right here. And then I'm going to subtract those 2 from my total. So now we have 14. And then we're going to reassess the needs of our atoms. So hydrogen still needs 0. Oxygen still needs 4. Carbon has 2, 4, 6, 8, so it doesn't need any. Oxygen has 4, so it needs 4. And then oxygen here has 2, so it still needs 6. So 4 plus 4 is 12, plus 6 is 4 plus 4 is 8, sorry, plus 6 is 14. Sorry about that. So that zeroes out, so now we can just apply our dots. Now, one last thing, since this is a polyatomic, we have to put it in brackets and put the charge on it. So I'm just going to clean this up a little bit now. Take away these. Put the brackets on it and put the charge on the outside. Remember, that's our ion notation. So that is resonance. We also have some exceptions to the octet rule. So we have boron can be deficient. It can only have 6 electrons in some cases. Phosphorus can have an expanded octet up to 10 electrons. And when I say below, I mean arsenic, antimony, and bismuth can also have an expanded octet. And sulfur and below, so sulfur, selenium, tellurium, and polonium can have an expanded octet up to 12. So we're going to work these in much of the same way. We just need to keep the exceptions in mind as we're working these. So we have one boron. Boron has 3 valence electrons. We have 3 fluorine. Fluorine has 7 valence electrons. So this is 21 plus 3 is 24. So boron is going to go in the center. We're going to arrange the fluorine around it. Single bond them. So we have 6 involved with bonding. Take that away from our total. 24 minus 6 is 18. So we have 18. Let's go and see how many do we need. Well, each of these fluorines is going to need 6. So that's 18. And we know that sometimes boron can be electron deficient and only have 6. Well, it has 6. So we have 18. We need 18. We are good. So now we can just apply the dots to our Lewis structure. So that is boron trifluoride. So now phosphorus pentachloride. So we have 1 phosphorus. Phosphorus has 5 valence electrons. We have 5 chlorine. Chlorine has 7 valence electrons. So that's going to give us a total of 40 electrons. We're going to put phosphorus in the center, and then we have 5 chlorine. We're just going to arrange those chlorine around the phosphorus. Try to make it as symmetrical as possible. We're going to single bond all of our atoms together. So we have 10 electrons involved with our bonding. So that leaves us 30. So we now have 30. One indication of an expanded octet is that what's bonded to the phosphorus is greater than 4. So we have to have an expanded octet. So now, assessing our needs, well, each chlorine has 2. We need 6 more to get to 8, so 6 times 5 is 30. So we have 30, we need 30. So then we can just apply the dots to our Lewis structure. So that is phosphorus pentachlorine. Now for sulfur hexafluoride. So we have 1 sulfur. Sulfur has 6 valence electrons. We have 6 fluorine. Fluorine has 7 valence electrons. So that is going to give us a total of 48 electrons. We're going to put sulfur in the center, and then we are going to arrange the fluorine around the sulfur. Again, we have the number of atoms that are bonded to sulfur is greater than 4, so we know that we have to have an expanded octet. The math is also going to line up with us. So we have 12 electrons involved with bonding, so we have 36 electrons. Each fluorine has 2, so it's going to need 6, so 6 times 6 is 36. So we have 36, and we need 36. Now we can just apply the dots to our Lewis structure. And that is sulfur hexafluoride. That is it for our multiple bonds, exceptions, and resonance. You have practice on page 16 in your packet, practice Q. Go ahead and work through that. You will have a quiz next time over Lewis structures, so make sure that you're ready for that. Thanks for stopping by. Have a great day.